section of Module 1, we're going to talk about absolute value inequalities. So we're basically combining sections 2, 3, and 4 into a single thing. So in order to solve absolute value inequalities, we talk about the two different types of inequalities. You have your less than or equal to, and then you have your greater than or equal to, because they have different types of solutions. So let's start with our less than or equal to. So we want to know what values will hold for the inequality. The absolute value of x is less than 3. So if you treat this like an absolute value equation, like if I have the absolute value of x equals 3, then for my two equations, I have that x can equal 3 or x can equal negative 3. So it's very similar with the inequality. I can have anything less than 3. So open circle at 3, everything to the less than that, right? Because everything less than 3 is less than 3. But if I take the absolute value of negative 3, I can also get 3. But it is slightly different because anything less than negative 3 is, if I take the absolute value, is actually greater than 3. So it's actually everything to the right of negative 3. And then we look, so when do they overlap? And they overlap for everything between negative 3 and 3. So my solution would be everything from negative 3 to 3 is going to work as my solution. So when it comes to solving absolute value inequalities, if the absolute value of x is strictly less than a, my solution is from negative a to a. If it were equal to, it'd be bracket negative a to a. So less than or equal to inequalities will have solutions that overlap on a number line. All right, so let's look at a couple examples. So we have the absolute value of x minus 2 is less than or equal to 1. So I have to set up two equations that we're going to solve. So my first inequality is just like when you are doing an absolute value equation. You're going to drop the absolute value. So if x minus 2 is less than or equal to 1. And when I solve my second inequality, I keep the x minus 2, but I flip my inequality and it becomes greater than or equal to and then negative 1. Then I'm going to solve each inequality. So we're going to add 2 to both sides and we get x is less than or equal to 3. And then add 2 to both sides of my second inequality, and we get x is greater than or equal to 1. So if I were to draw a small little number line, I have 1, 2, and then 3. For my first, for the x less than or equal to 3, I'd have a closed circle at 3, everything to the left of that. And then for everything greater than or equal to 1, closed circle, everything to the right. So they would overlap between 1 and 3. So my solution is bracket 1, comma 3, and close bracket. For my second inequality, I have the absolute value of 5x plus 2/7 is less than or equal to negative 4. So when I set up my two inequalities, we'll have 5x plus 2/7 is less than or equal to negative 4. And then our second one will be 5x plus 2/7 is greater than or equal to 4. And then I'm actually, for my first step, going to get rid of my fraction. So I'm going to multiply everything by 7, which is my LCD. And we end up with 35x plus 2 is less than or equal to negative 28. Now I'm going to solve my inequality. Subtract 2. So we get 35x less than or equal to negative 30. Then we're going to divide both sides by 35. And we get x is less than or equal to negative 30 over 35. I'm going to leave it as a fraction and I'll explain why in a little bit. So for my second inequality, again, my first step is going to be to multiply everything by 7. We're going to get 35x plus 2 is greater than or equal to 28. First step is still to subtract 2 from both sides. But this time we get 35x is greater than or equal to 26. Then divide everything by 35. And we're going to get x is greater than or equal to 26 over 35. I'm going to leave these as fractions and I'll show you why here. So it doesn't matter what negative 30 over 35 is. So wherever that falls on the number line, 26 over 35 is greater than that. With my solutions, everything less than or equal to negative 35, close circle everything to the left. For everything greater than or equal to 26 over 35, close circle and everything to the right. So if I'm looking at my solutions on my number line, there is no overlap. And the requirement of an absolute value inequality, which is a less than or equal to, is that my solutions have to overlap on my number line. And since they don't, this is an example of no solution. So no solution is a little bit different here for an absolute value inequality. So if I go back to my original inequality, I had the absolute value of 5x plus 2/7 is less than or equal to negative 4. And if we think back to an absolute value equation, we said that the absolute value couldn't equal a negative. It looks slightly different for inequality. So in this case, an absolute value can never be less than a negative number because whatever I plug in for x here, I'm always going to get a positive solution. So if you're looking at an absolute value inequality, it's no solution because an absolute value is never less than a negative number. So you're never going to evaluate an absolute value and get something that's less than a negative number. So let's talk about the second type of absolute value inequality, and that's everything that's for greater than or equal to. So we go back to our absolute value of 3, but now we're going to look at the absolute value of x is greater than 3. So we already talked about the fact that you have solutions at 3 and negative 3. Okay, that doesn't change. But if I think in terms of where my solutions are, everything to the right of positive 3, when I plug in, I get something greater than 3. And then the reverse side, if I want to plug in something that's a negative number and still get something that's greater than 3, I want to pick everything to the left of negative 3. So in this case, my solutions are not going to overlap. I'll have negative infinity to 3, and then the union, and then 3 to infinity. So when you have an absolute value inequality greater than, you're always going to have two solutions. So for an absolute value of x greater than a, my solutions are negative infinity to negative a, parenthesis, and then union a comma infinity. And then again, if it's an equal to, it'd be negative infinity to negative a with a bracket, and then the union bracket a comma infinity. So because our solutions are or, the greater than or greater than or equal to inequalities do not have to overlap on a number line. So let's do a few examples. So for our first example, we have the absolute value of x plus 2 is greater than 4. So my first inequality, x plus 2 is greater than 4. The second inequality becomes x plus 2 is less than negative 4. So just like with greater than, less than inequalities, for your second inequality that you solve, you have to flip the inequality and make the number negative. So we're going to subtract 2 from both sides, and we get x is greater than 2. For the second inequality, also subtracting 2, and we get that x is greater than negative 6. Sorry, less than negative 6. So for my number line, if I were to look at this, we have negative 6 and 2. Everything greater than 2 would be open circle, everything to the right. Everything less than negative 6 would have an open circle, and then everything to the left. So for my interval, I'd have negative infinity, comma, negative 6, parenthesis, then my union, parenthesis 2, comma, infinity. So for our second inequality, we have the absolute value of 5 times x plus 3 all over 2 is greater than negative 2. So instead of solving this, I'm going to kind of relate it back to our first example. So if an absolute value can never be less than a negative, on the reverse side of things, an absolute value will always be greater than a negative number. So we are looking at something on the reverse side. So this one is not no solution. Just because you see a negative number with an absolute value inequality does not necessarily mean no solution. It's dependent upon whether you're looking at a greater than or a less than inequality. So in this case, absolute value will always be greater than negative number, which means I can plug in any number for x here. So my solution is negative infinity to infinity. Because I can plug in any number for x, I will always get something greater than negative 2. Right. And then for our last example, we have the absolute value of x plus 1 plus 11 is greater than or equal to 19. So just like when we're solving absolute value equations, in order to solve an absolute value inequality, you first have to isolate it. So my first step here is actually going to be to subtract 11. And then we have the absolute value of x plus 1 is greater than or equal to 8. This is the inequality I use to set up my two inequalities. So I have x plus 1 is greater than or equal to 8, and then we'll have x plus 1 is less than or equal to negative 8. So I'm going to subtract 1 from both sides to solve. So we get x greater than or equal to 7. And then same thing for my second inequality, we get x less than or equal to negative 9. So if I'm looking at a number line here, I have negative 9 and 7. Everything greater than or equal to 7 would be a closed circle, and everything to the right. Everything less than or equal to negative 9, closed circle, and everything to the left. So then I would have negative infinity, comma, negative 9 with the bracket, and then union bracket 7, comma, infinity. So please let me know if you have any questions about solving absolute value inequalities, whether that's how do we set up the two inequalities we're going to solve, or how to write the solutions using interval notation.